Right, good afternoon, everybody. My name is McCarthy. You'll have heard mention the Seeing What They See project a couple of times today already. And part of that project was a collaboration between the Department of Civil Engineering here at UCL and the Dementia Research Centre. And the work was done at the Pedestrian Accessibility and Movement Environment Laboratory. Now, that laboratory is almost universally known by the acronym PAMELA, for reasons that you can probably guess. PAMELA is a laboratory in which we can create spaces for people to move around in. We can then study how they move, identify problems, and then try to come up with solutions to solve those problems. So what I'm going to do this afternoon is describe in general some of the things we can do at PAMELA. Then I'll describe how we set it up for the Seeing What They See project and give an example of some of the measurements that we could take. Then I will pass on to my colleague Keir, who will then summarize some of the results and conclusions so far from the study. Right, so this shows 4 examples of the sort of thing that we do in PAMELA. In the top left, the basic floor of the whole laboratory is a modular concrete system, and we can arrange that to create various objects, if you like, that you could see in the built environment, like a step representing a curve or a cross slope or a longitudinal slope. So we configure it like this for studies for wheelchair accessibility, for example, and I've used it to study in general how aging affects how people can get around in the city. We have a very sophisticated lighting system that control not only the intensity of the light from a very bright day to virtual darkness, but you can also change the colour balance very continuously as well. And there are ongoing projects with the Institute of Ophthalmology as well. On top of the basic platform, we can create rooms or corridors or mazes for people to walk around in. And the most complex thing that we do is create a tube carriage. Now, you may have heard the phrase mind the gap. And one thing that we do is assess how the size of the gap affects the rate at which people can get on and off a tube carriage. Now, this shows 3 examples of how we set up the laboratory for the Seeing What They See project. I think in total we did 7 or 8 separate scenarios, is that right? There's no time to go into all of them in detail, so I'll describe just these 3. This first one we called the corridors task. We asked people to walk from the start to the end of a corridor. We had 3 types of corridor. We had a simple straight one. We had a U-shaped corridor, which had 2 turns of the same direction. Or we called a dogleg corridor with a turn one direction, then another. What we're able to do here is to change the light level so we had a high light setting and a low light setting. We also had the option of having floor level running LED lights to see whether that would be beneficial. The second example, this is what we called the doors task. People were asked from the position taken from this camera view and to walk towards the open door on the opposite side. The actual door the position of the door could be varied. What we were testing here is whether a visual cue, as you can see there, would make things more efficient and more effective in reaching that door. The third example here is what we call the shadows task. This is a room with a lot of furniture providing clutter. And again, people are asked to walk from one side to the open door. The lighting could be configured either to have a high contrast shadow condition or with the same overall general lighting to have virtually no shadow or a very low contrast for the shadow. The idea of being able to set up things like that is that we could get quite a number of people to walk within identical spaces. So rather than rely on anecdotal evidence saying, oh yes, highlight is important or shadows are bad, we could assess a number of people in the same conditions to try and get some more objective evidence. Now, in order to assess how well people were doing, the main measurement was going to be the time taken to get from the start to the end. So either time to go from the start of the corridor to the end, or from here to there, or from there to there. But we also wanted to understand more of how people were moving within this space, so we get a better understanding of how they were interacting with that. So to do that, we used devices such as this. These are called inertial measurement units. They measure acceleration and they can measure angular velocity. And for all the trials that we did, we put one on each foot. And so from recording the accelerations, we could work out not only how people were walking, but where they were within the space. As our familiarity with the technology increased, in trials towards the end, we also put one of these sensors on the head, so we could see how people were moving their head while they were walking through the space. And so we did a number of trials with people with PCA and memory-led Alzheimer's, as well as controls, asymptomatic controls for a similar age. Now I'm just going to show a couple of animations to illustrate the sort of things that we observed and some characteristic ways in which people were walking. This is an example from walking along a U-shaped corridor. This is a plan view of the corridor. The white lines represent the walls. The red and the green dot represent the position of the left and the right foot, and the person has to move from there to there. The first I'm going to show is for a control person. And he is striding out quite well, and he's adapting to the requirement of having to turn in this bend. I'll now run this for someone with PCA. You can see he's walking quite a bit slower. And then when it comes to the corner, he's hesitating. He actually has to step back. And then when it comes to this corner, he doesn't hesitate so much, but he still takes a right-angled turn rather than a smooth turn. So in all the control people we measured, they were very similar to this. For the people with PCA, there was a much broader range of responses, but this illustrates some of the characteristics that we saw, that in general, people walked slower, and secondly, when it comes to adaptations expected when they came to a corner, they did not necessarily follow an optimum path, and they often hesitated to make a decision of which way to go. That was seen in a number of people, but to a greater or lesser extent in than this. Not always exactly like this. Right, what I'm going to show now is an example from the shadow experiment, as you see here, and this is a plan view. So the yellow rectangles represent the tables there. The green represents the chairs and the stool, and the dark grey rectangles represent the shadows in the room. Now, as before, the red and green dots represent the position of the foot. The black line there now represents the direction in which the head is pointing, while the person is walking. The length of the line is completely arbitrary, it's just the direction is important. And I'll run the animation first for this control person, and the point to look out for is that you can see it's almost immediately the direction in which the head is pointing is directed towards this target door, and it remains pointed towards that door for most of the trial. Now I'll run this for someone with PCA, and you should see that he is looking around quite a bit before starting to walk. He's walking slowly. He is looking around mainly to the right, even though he's meant to go to the left. Then, even after he sets off, he has to take a step back when he comes to the shadow. So again, this illustrates some of the characteristics we saw with people with PCA. Often, before starting, there was a significant delay while they looked around scanning the room. That was a characteristic. And secondly, that there was frequently a problem with the shadow. So those are a couple of examples that I think are illustrative of the types of movement that we saw. But to summarize the results overall now, I'll pass on to Keir. Thank you.
Great, thank you, Ian. So as Ian mentioned, in total we carried out 7 pilot investigations within the PAMELA lab. All these investigations were inspired by the perspectives of people living with posterior cortical atrophy regarding certain day-to-day visual symptoms they were experiencing, or some of the neuropsychological research that Seb outlined earlier, or more recently, some of the aids and strategies that people were already implementing within their own homes, which were neatly summarized by Emma Harding. And in the interest of time, I'm just going to outline in particular detail 3 example tasks carried out within the PAMELA lab. So these were, as Ian mentioned, looking at the effect of visual cues on people's ability to reliably reach certain destinations, effects of the quality of lighting on navigation, and also the effects of clutter on people's ability to reliably locate objects. So for this task, as previously mentioned, people were asked to walk to one of 3 destinations within this open plan room. And to give a sense of what it was like from the perspective of a participant carrying out this task, this is a video taken from the point of view of a lady living not with a diagnosis of posterior cortical atrophy, but with more memory-led Alzheimer's disease. And the circle just shows her recorded position of gaze as she's performing this task. And unfortunately, I'm just about to rudely interrupt my own videos. So I think you get a sense at the beginning of this recording that she's taking that much longer to locate where that target destination is. Although having fixated the door frame, she gets across the destination without any obvious difficulty. And a recurring theme throughout any of the PAMELA investigations is figuring out, well, what are the optimal conditions of the physical environment for people living with posterior cortical atrophy and more memory-led Alzheimer's disease to reliably and confidently reach certain destinations and objects. And so this first task, our interest was in figuring out whether the use of certain simple visual cues might promote more efficient reaching of certain destinations. And while visual cue is a term that might not seem particularly intuitive or transparent, I think it's helpful thinking of these cues as sorts of everyday signage that we might use to mark out a certain destination, or the sort of things we might use to navigate certain complex environments by, say, something that's particularly salient or jumps out at you. And in this case, we were interested in the use of 2 visual cues, the first of which made a change to the contrast, so with the introduction of a dark box on the door frame, and with the other being the same contrast box but emitting a moving light pattern. So some of our interest in using these moving light patterns really followed from some reports of people with posterior cortical atrophy who seemed to mention that they were particularly sensitive to being able to perceive objects which were moving rather than stationary. And regarding the results from this task, so involving a group of people both with posterior cortical atrophy and more memory and Alzheimer's disease, we found evidence that overall people were more efficient with the use of the contrast cue regarding their ability to reach destinations. However, we didn't find any evidence for the use of the contrast cue but using this moving light effect, suggesting that even if some people individually might be to find these approaches beneficial, we didn't really seem to find a consistent effect involving our overall group of participants. One of our reasons for carrying out these formal investigations of people's everyday activities within this accessibility lab are related to the sometimes quite counterintuitive and striking perspectives of people living with PCA. So in some cases saying things such as, well, in fact, bright lights are not very good at all. Strip lights in particular, it's almost as if it's like there's a lot of a small space with lots of light coming from all different directions. That's what it feels, that's what it's like. And correspondingly, as you've heard earlier today, for some people with PCA, they'll be reporting things such as heightened sensitivity to glare or very shiny reflective surfaces, or things that make it that much harder to be confident of really estimating the depth of certain surfaces and flooring. And as you can see from this picture here, this is an example of where you might have a combination of inappropriate contrast and lighting, whereby it's not hard to imagine why, for someone who's experiencing even some subtle visual impairments, it could be quite hard to be confident about the depth of that surface. And so correspondingly, we carried out a systematic investigation of the effects of the quality of lighting in terms of its consistency rather than its overall level, so say bright versus dark. And for this task, we involved a group of people with posterior cortical atrophy and found that looking at 3 shadow conditions, so going from left to right, high, medium, and low, that participants with posterior cortical atrophy were at their most efficient reaching destinations under the low shadow condition when we're ensuring more consistent ground lighting. Through the capabilities offered via the PAMELA lab, we're able to get a sense not just of people's time taken to reach certain destinations, but also some of the characteristics of their movement. So indicated in grey here, we can see the paths people have taken to different destinations. So this is to both left and right-hand side doors, but also points along paths that people are particularly hesitant. And these are indicated here in these markers. And again, we found evidence that under the lower shadow conditions, that these were associated with reduced rates of these very hesitant and slow steps. And going back to more simple investigations involving stimuli to get an idea about people's difficulty perceiving objects amongst clutter, so for example using individual letters, numbers or words, that we wanted to carry out a more real-world investigation of people's ability being able to locate everyday objects, but amongst different amounts of clutter. So for this task, we'll be asking people to pick up the blue cup that you can see here, but either presented in isolation or surrounded by 2 or 5 distractor objects. And again, with our main measure of task efficiency being time taken to pick up the cup, we found that for both control participants, as well as participants with more memory and Alzheimer's disease, we're not seeing a particularly prominent effect of clutter on people's ability to reliably locate objects. However, looking at the performance of participants with posterior cortical atrophy, you get a sense of this elevated effect of visual clutter on people's ability to locate objects, although actually when locating objects in isolation, their performance is reasonably comparable to that of people with more memory than Alzheimer's disease. And so while I reviewed some quick example tasks looking at the effects of visual cues, and we found suggestions that the use of contrast cues, ensuring more consistent lighting and minimizing clutter, has suggested some benefits in terms of people's ability to reach destinations or objects. It's worth emphasizing these at the group level of participants. Obviously, everyone's very different. And furthermore, I haven't had time to outline certain tasks where, if anything, we found little to no evidence of benefits of certain environmental adaptations or aids. So something we were surprised by in an early task is actually by boosting overhead lighting, we didn't seem to find evidence of a benefit on people's ability to navigate certain routes, although it's possible that a certain unintended consequence of boosting the overhead lighting was creating these stark areas of light and dark. Another task involving stair climbing found no evidence of benefits of the use of hazard tape. So I guess we're all familiar here of this diagonal black and yellow tape, where anecdotally participants mentioned things such as, even though it makes the contrast more apparent, it's actually these jagged yellow and black lines that, if anything, make it more difficult for me to be confident about the exact edge of a step. And finally, I think referring both to the lack of evidence in terms of the use of this motion cue, as well as a lack of evidence in terms of the benefits of LED strip cue that Ian quickly outlined, that I think further research is needed in terms of the basis of this potential relatively preserved perception of moving rather than static objects. And just to finish off, one of the advantages of the PAMELA lab is also one of its limitations, where it gives us a great control over low-level aspects of the physical environment, but it's by no means an everyday setting, and there's still questions on what actually constitutes clutter in someone's everyday home relative to a setting such as this. And I'd just like to thank in particular all the people who so generously volunteer their time towards taking part in research, and all the people involved in the study, and you for your attention. So thank you.